Good morning, Mr. Thomas. So today's question is, can you explain your approach to software architecture?
Yeah, good morning, Lavanya. Thank you. Thank you for the question. First of all, I'll explain what is an architecture. We all usually hear the word architecture when it comes to building or constructing, a civil structure, a home or an office building. That is where we usually hear this word called architecture. But in software also, there is a concept of architecture. It is basically the structure of development. So when a software programmer or a team of software programmers, they come together and they develop a particular software, there is a structure or a classification or categorization of the coding that happens. Okay, that arrangement of the coding is what they call as architecture. uh, Now the first thing is, most of the customers, they really do not want to know what is the architecture, because they don't want to get into the how the software works under the hood. They just want to know if the car is running. They don't want to open the bonnet and see where is the engine, where is the spark plug and all that. They just want to see how it is running. So most of the clients, they do not know what is an architecture. They're not interested to find out what is an architecture. They are interested to know, this is my problem. Does your software solve this particular problem? Does it give me the solution? Will it help me to grow my business? Will it help me to make more revenue and money? However, on our side, when we develop the software, it is extremely crucial that we understand the requirement, the kind of bandwidth that is required for the software, the kind of load that will be on the software, the type of solution, the traffic that is expected onto the software. So we try to understand all these, because as a developing organization, we have to design the architecture to fit the requirement of the customer. Okay. So, so what typically happens is, in architecture, there are four layers. The first one is the usage layer, that is the front end, that is where the customer actually uses the software. Then there is a layer called as interface layer, which is not present in most of the softwares, but it is a layer which communicates with other softwares, or many even architectures don't even mention this. The third layer is logic layer or the backend layer. Now that is where most of the functionality, most of the logical, execution and all that happens on the backend. Of course, in the front end also there is execution, okay, but most of the logic happens on the backend. And then the fourth layer is database, where all the data is stored into tables or files. And these are the four layers: usage, interface, logic, and or front end, interface, backend, and database. So these are the four layers. Now, in terms of architecture, what we do is, whenever the software is extremely simple and the client has no idea of scaling it up, and it is going to remain almost the same for the next 5 or 10 years, there's not going to be much of a difference. What we will do is, we will do a direct coding. That is, there will not be a defined back end or a front end. There will not be any change like that. The whole coding will be into a single process, and the development will be completed quite fast. That's a direct coding approach. But if it's a medium-sized requirement where there are, let's say, around 50 users who are going to use it, and there might be a chance of scaling it up, then what we will do is, we will use a structure known as MVC, or Model View Controller. That is, the front end and back end will be very clearly defined, and the front end development and the back end development might be handled separately by different team members also. So the advantage of this is, it will help easily to scale up. It will help to add more team members, and it will help to even maintain the code better when it gets larger and larger. So this architecture is what we would recommend for that. Now, one more architecture which is quite common nowadays is a microservices architecture. That is, if the organization is very large, or if the number of users is very large, okay, simultaneously there are thousands of users using the particular portal or software, then in that case, there is an architecture called microservices, where each service or each part of the software is divided into services, and they run independently of each other, and they just talk to each other through API connections. So that microservices architecture becomes extremely crucial if the software is very large, and it is scaling up in a very fast level. The number of modules being added are very fast. So we also use appropriate programming languages for different types. Like, for example, if it's a direct coding, we may use something like PHP. But if it's a microservice, we may use something like Node or Java. So these are the ways we ensure. But as I said in the starting, most of our customers, they really do not want to know what is the architecture because it's not required for them. They just want to use the solution. They just want to use the software at the end of the day. So we ensure that the solution that we create, we understand the requirement and we align our solution with the requirement correctly so that they can use it correctly. Yeah, so that is the way we do it, Lavanya. Thank you for asking.
Thank you.
Thank you.